In this discussion, we're going to look at a problem-solving technique called factor label, also sometimes referred to as dimensional analysis. Basically, what we do in factor label, and I'll give you some specific examples as we work through the problems, is that we are stringing together multiple ratios. So this is just a really quick way to do problems that involve more than one ratio. And the general format, if you're not already semi-familiar with it, is that you have a given value and you're going to take that given value and you are going to use one or more what we call conversion factors. To change the unit of the given value into some other unit or set of units. Okay, so the thing to remember is we're really not changing the quantity that we're dealing with. We are just going from one unit to what its value would be in another type of unit. Okay, as such, what you will see is that these conversion factors that we have are always going to be things that are equivalent to each other. Just some ones that you may be familiar with. For example, if we said that 1 foot equals 12 inches, all right, if I were to use that in a factor label as a conversion factor, I could either write it as 1 foot over 12 inches or 12 inches over 1 foot. Okay? In any case, the amounts on the top and the bottom of my conversion factor are equivalent values. And so that's the thing to keep in mind, that we're looking at equivalent values, and the way that we use them is going to be based on what the unit is of the thing that we're starting with. So, for example, say I had here, let's say 24, we'll do something really easy, 24 inches, and I wanted to know how many feet that is. All right, so I want inches on the bottom because we want to cancel out the unit that we're moving away from. In this case, I have inches. I don't want inches. I want feet. So inches to feet. And we know that that relationship is 12 to 1. All right. So that would give me my inches cancel, and my ending unit would be feet. And so I would have 2 feet is my answer there. Okay. Now, here is a table that you've probably seen before. This gives the values for the prefixes in the metric system. And so I'm going to show you how we're going to use these values in our factor label, because sometimes that seems to be a source of confusion with people as to how to incorporate these values here. So say we're going to convert 121 grams to centigrams. So I have 121 grams, and I want to know, do I have a relationship between grams and centigrams? Well, based on this chart, I would. Grams to centigrams. Okay, and this tells me that the relationship here, what this means is that 1 centigram is 1 times 10 to the minus 2 grams. Okay, so if you're going to use the values straight off of this chart, you want to put a 1 with the prefixed unit, and then use the exponent in the chart with your base unit. So here I would say that 1 centigram is 1 times 10 to the minus 2 grams. Then to find my value, I'm simply going to multiply things that are on the top and I divide by the things that are on the bottom. So this would be essentially 121 times 1 divided by 1 times 10 to the minus 2. Okay, and the ending unit again is going to be centigrams. And so that's going to give me 121 divided by 1. So that gives me 12100. Oops, sorry, centigrams in there. Okay, 12,100 centigrams. Okay, let's look at another. What if we're going from a prefixed unit to another prefixed unit? Okay, well, the easiest way to do these and get the right answer is to basically go from one prefix to the base and then to the next prefix. Okay, because then we can use these values that are on this table. So if I have 8.012 times 10 to the 14th, it's a microgram. All right, and I'm going to lay out my units first. Sometimes it really helps if you will lay out the units first, essentially just to make sure that when you finish that you're going to be in the correct unit. Okay, then go back and put in the number values that go with those conversion factors. Kind of focusing on each thing separately to avoid making mistakes. So here, microgram, if I look, microgram is 10 to the minus 6. So that is 1 microgram, remember the 1 goes with the prefixed unit, is 1 times 10 to the minus 6 grams. And again, same thing with here. 1 centigram is 1 times 10 to the minus 2 grams. Okay, so I'm going to solve this, I'll do 8.012, 10 to the 14th, times 1 times 10 to the minus 6, and divided by 1 times 10 to the minus 2. And that gives me 8.012 times 10 to the 10th, and my unit on that would be centigrams. Okay, we can also use factor label to go between units in the English system and metric units. So let's look at this. Here we have 11.9 ounces is equal to how many grams? Okay, so my given value, ounces, okay, and then I want to know, let's see if I can go from ounces to grams. Well, looking at my conversion table, I have, okay, yes, I do have one. Okay, I have that 1 gram is 0.03527, 0.03527 ounces. Okay, so my ounces cancel. My ending unit will be grams. So 11.9 divided by 0.03527 is 337 grams. Okay, now we can also apply a factor label when we have these combined units, like for example miles per hour, meters per second, like we have in this case. So let's take a look, and here we have a word problem, and I know some of you have told me that word problems are not exactly your strong point. So let's look at how we would dissect this. The thing to remember about these is essentially in every case you're going from something that you know, the givens, to something that you don't know. Alright? And the process of solving the problem essentially involves finding connections between what you know and what you don't know. Alright? So let's see, what do I know? Well, I know that this plane did 12,193 miles per hour, and I want to know the speed in meters per second. Okay, to do this, I'm going to look at the two units separately. So I'm going to look at how would I get from miles to meters and how would I get from hours to seconds, and we can treat those completely separately. So what do I know? Well, I know they give me that a kilometer is 0.621 miles, and I know from my metric chart, okay, so that would get me to kilometers but not to meters. Well, but from the metric chart, I know that 1 kilometer is also equal to 1 times 10 to the third, or 1,000 meters. Okay, and then as far as hours to seconds, I know that 1 hour is 60 minutes, and that 1 minute is 60 seconds. Okay, so we're going to use this. Here's miles to kilometers, kilometers to meters to get me from miles to meters, and then I'll use the second two conversion factors to get me from hours to seconds. So we start with, and let's just lay out this. Now, when you have a combined unit like this, you're going to put the top unit up here, and this essentially means 12,193 miles in 1 hour. So we're going to put those in the top and bottom. And so if I want to convert this top unit, all right, let's do that one first. So I can go from miles to kilometers, and then I can go from kilometers to meters. All right, and once I do that, there's my ending unit. So I'm done with the top part. Now let's look at the bottom. To cancel hours, here I need it, since it's on the bottom, I need it on the top. So hours to minutes, and then minutes to seconds. Okay, so now we should have, with our units canceling, right? Okay, that leaves me in meters, hours to hours, minutes to minutes, and that leaves me with meters per second. So that's the unit I want. So here I'm going to use that 1 kilometer is 0.621 miles, and 1 kilometer is 1 times 10 to the third meters. Then here is where I'm going to use 1 hour is 60 minutes, and that 1 minute is 60 seconds. Alright, so let's put all that together. Our ending unit is going to be meters per second. And to solve this, I do 12,193 divided by 0.621 times 1 10 to the third, and then divided by 60 and divided by 60. So that gives me 5,454.0 meters per second. Okay, the nice thing also, you should have already looked at the discussion on significant figures, and since factor label involves multiplication and division, basically you're going to use the number of significant figures in your given that you start with, and your answer will have the same number of significant figures in it. Okay, let's look at another one here. Where we have a combined unit. Here I want grams per cubic centimeter. So that's my known. I'll just use a K. Alright, my unknown is what is that value if the units are kilograms per cubic meters. And then my connections, let's see, what do I know? Grams to kilograms. Well, I know 1 kilogram is 1 times 10 to the third grams. So I can do that pretty easy. And then cubic meters to cubic centimeters. Okay. When you're dealing with cubic units or squared units, okay, the conversion factor you use is actually quite easy. Alright, the easiest way to do this is if you take the regular relationship between the units. So in other words, 1 centimeter is equal to 1 times 10 to the minus 2 meters. Okay, that's right off the table. Now, I can cube this unit as long as I also cube the number that goes with it. Okay, this is just in dealing with your conversion factors. So if I want to get a conversion factor between cubic centimeters and cubic meters, okay, I can set it up with the regular relationship between centimeters and meters and then cube those values. So if I go ahead and write this out, this tells me that 1 cubic centimeter is going to be, if I do 1 10 to the minus 2 and cube that, I get 1 times 10 to the minus 6 cubic meters. Okay? So let's set that up. We have 8.3 grams per 1 cubic centimeter. Okay? Then let's just do our grams first. So grams to kilograms, I can do that in one step. And then for the bottom, cubic centimeters to cubic meters. Okay, I can do that in one step. So 1 kilogram, 1 times 10 to the third grams, and 1 cubic centimeter is 1 times 10 to the minus 6 cubic meters. So 8.3 divided by 1,000 and divided by 1 times 10 to the minus 6. So that gives me 8,300, and my ending unit, grams cancel, cubic centimeters cancel, is going to be kilograms per cubic meter. Alright, let's look at this one here. Here I have, and this is kind of a common problem that you'll see, I have a box with the dimensions 14 by 8 by 3 centimeters, and it has water in it. And it wants to know what weight does this amount of water have. Well, alright, look at this word amount. Amount here, how can we get an amount? Well, the amount that we're going to be able to find is the volume, right? Because we have the dimensions of the box. So my volume is going to be 14 centimeters times 8 centimeters times 3 centimeters. So I get a volume then of 336 cubic centimeters. That's what we know right there. And what do I want to know? It says, what weight does this have? And actually, that is not a good term. Let's use the word mass. Okay, and it doesn't tell us what unit it wants it in, so let's make it simple, and let's do grams. Okay, now, looking at this, all right, what are my connections between the volume that it gives me and finding out how many grams of water that is? Okay, that's the other known I have, is that the substance is water. Well, think about it. What's the relationship between the volume of a substance and its mass? Well, that is its density. Density is mass per volume. Okay, so what do we know about the density of water? Well, in problems like this, where they don't give you a density and the substance is water, it's okay to assume that the density of water is 1 gram per cubic centimeter. Okay? So there's our connection between the two things we want. So 336 cubic centimeters, that's our starting value, and that is of water. All right, and I want to go from cubic centimeters to grams, and so my density says that 1 cubic centimeter is 1 gram, which means that 336 grams is the mass of that amount of water.